Assalamualaikum and good day everyone. Today we'll be going through Module 2 Part 1, which covers descriptive statistics. This is a foundational topic in data analysis and forms the basis for more advanced statistical techniques. By the end of Module 2, you should be able to explain two major categories of statistics, descriptive and inferential. Let's start with descriptive statistics. This refers to methods used to organize, display, and summarize data. Think of it as making sense of data at a glance, like calculating averages, percentages, or presenting information in graphs or tables. Some real-life examples: percentage of workshop participants, the average salary in a company, or how many students are satisfied with their university. All statistical analysis begins with descriptive statistics. Before jumping into models or predictions, we must first understand the structure and characteristics of the data. This is usually the first step in any scientific or research discovery. Descriptive statistics are divided into three main types: frequency distribution, summary statistics, and graphical representations. This helps us organize and visualize both qualitative and quantitative data clearly and concisely. Frequency distributions organize raw data into a readable format. Raw data is data recorded in the sequence in which they are collected and before they are processed or ranked. A frequency distribution is the organization of raw data in table form using classes and frequencies. For qualitative or categorical data, we list each category and the frequencies it appears. For example, in a survey about job-related stress, we would count how many individuals fall into each stress level category. From the frequency distribution, we can also count relative frequency and percentage as shown in this slide. With quantitative data, we do something similar, but with numerical values. We divide data into classes and count how many values fall into each class. This is often referred to as group data. To create a good frequency table, we need to calculate class boundaries, class width, and midpoints. Class boundary is a midpoint between the upper limit of one class and the lower limit of the next. Class width is the difference between boundaries. Class midpoint is the average of the lower and upper class limits. And that brings us to the end of Part 1. In Module 2, Part 2 will continue with inferential statistics.